Hi everyone, I'm Luca from on.lab, and today I'm going to introduce you to SDN IP. So SDN IP is an ONOS application that allows you basically to scale your SDN network and connect to the rest of the internet. Basically allowing your SDN network to become a transit network. Since SDN IP uses to do this BGP, it becomes easily for you to incrementally migrate your actual system to SDN and to scale your control plane with solutions like BGP confederations. So let's have a quick look of how SDN IP works. So in a typical scenario, you have an SDN network composed by different OpenFlow switches that are, of course, controlled by ONOS. ONOS runs as a cluster comprised of multiple instances of ONOS, providing high performances, HA, and scalability. And then we have, of course, the external networks that attach through their BGP routers to us, directly into the data plane. Also, SDN IP exposes two objects that are called BGP speakers. What we mean for BGP speaker is any hardware or software box that can speak BGP with the external routers. So also these two BGP speakers are directly attached into the data plane. And then we have, of course, SDN IP that is installed on one or more ONOS instances that is connected to the BGP speakers. So only one instance of SDN IP is active at the time, while the other ones stay in standby mode and wait in case the primary fails. When SDN IP starts up, it reads the configuration file that contains the details of the peering session. And at this point, it's created a point-to-point intent between the router, the external routers, and the BGP speakers. The BGP sessions are established, and the external routers start to send the BGP advertisement to the BGP speakers that advertise them to SDN IP. So SDN IP then translates these BGP routes into OpenFlow ONOS intents requests, and ONOS itself translates these ONOS intents into OpenFlow entries on the switches, thus enabling the communication between the external routers. So for the demo of today, you already see something on the other screen. We decided to do something a little bit different that I hope you like, which is through the features provided by Mininet Cluster Edition to distribute both the data plane and the control plane components into the cloud. So what we did was distribute the Mininet Cluster Edition nodes all around the country. And what you will see in the demo is really the communication between devices that are actually on the West Coast to devices on the East Coast. Okay, so this is the moment I guess you were all waiting for. So let me move forward. So I use both of the screens, right? So the idea here is we have the schema on the left, and I will do you step by step what we are going to do. And then we have the real ONOS GUI on the right, and we will perform the same operation. Helping me here, we have John, that is our main developer for SDN IP, that will help me to show you what we will do step by step. Okay, so first of all, here we have, of course, a quite complex scenario. We have the SDN network in the center and different external networks distributed around, connected directly with their BGP routers. This is represented on the map. You see all the data plane components geographically distributed. And sorry, I need to run back and forth, but so this icon here represents a BGP speaker, while this icon here represents an external router. On the top left corner, we have the three ONOS instances that are represented here in the picture. Of course, everything is managed by an ONOS cluster running with three ONOS instances. We have, of course, also SDN IP installed on all the instances, but just on the first instance, SDN IP is active and running, while the other two instances have just SDN IP that is in standby mode, waiting for a failure. We have, of course, also all the three BGP speakers. I showed you the icon before on the map. Those are connected with a full mesh and with BGP, of course, to our SDN IP. And then these light blue arrows represent their connection into the data plane in the core switches. So the very first thing I want to do is to show you, first of all, that the SDN IP is already active and running. So potentially all the networks could speak already all-to-all one each other. First of all, I want to show you that we have the peering sessions in place. So if I click on a BGP speaker, for example, these show me graphically on the GUI the path from the BGP speaker to the external router the BGP speaker is peering with. Of course, the same behavior is expected when I move to the other BGP speaker, and I will have other paths that indicate me their BGP peering session. Okay. So the very first thing I'm going to do is to ping from the networks on the West Coast to the networks on the East Coast. Okay? So precisely from network 1 to network 4, network 2 to network 3. To do this, first of all, I can show you graphically, multi-selecting the nodes, that we have different patterns of traffic in this network. Why? Because for now, the GUI is showing us all the paths of traffic for all the exchange networks between the West Coast and the East Coast between these two routers. So, to tell you that to demonstrate to you that I'm not lying, I show you also the ping command. Okay, so host 1 to host 4, it's communicating, and host 2 to host 3, right? So basically, networks behind this router, and we have an host here, are able to communicate with the host on the other side behind the other router. All this is great, is wonderful, but we want to show you also that we are able to react to different failures. So I want to start to kill different components, both in the control plane and in the data plane. Let's start from killing the first ONOS instance. What we expect is that the second ONOS instance take over the failure, and the network, the ping will still continue flow. We should see the feedback here in the GUI. Go ahead. Thank you. So as you can see, the first instance became gray. We didn't lose anything in the ping. And honestly, of course, you can imagine, nothing happened in the data plane because we already had flows there, right? But if you come later at the demo, I can show you also that we are able immediately to push new routes into the control plane, and everything survived. For now, you just have to believe me. So the next thing I'm going to do is to kill the second BGP speaker up there, and these are represented here by this icon in the GUI. Okay? As you can see, the BGP speaker disappeared. We lose, it's difficult to see sometimes we lose some pings. Why we lose those pings, you will see it also later, is due just to the BGP convergence time. Of course, you know you can set these timeouts all around in your network on the routers. Now, let's start to kill things instead in the data plane. If you see here, I want to kill the first link connecting network number 1 to the SDN network. So here I just require you a little effort. If you see here, network 1 is connected through one router to the SDN network. In the GUI, you see two routers. Why? Because ONOS intercept the packets from the two interfaces with two different MAC addresses. So now the two interfaces are recognized and represented as two devices. But please, imagine it's one device. Okay? Okay, let's go ahead. Let's kill the link, please. Okay, thank you. So, as you can see, we are losing some pings because BGP is converging. By 10 seconds, we should see the network coming back. Okay, here we go. The communication came back, and everything is working just fine. The communication is still there thanks to the second link. Last but not the least, on the other side, let's kill the first router connecting network 4 to the SDN data plane. Of course, as same as before, it's a very similar use case. The second router will take over and the communication will go through it. Please, John. Thank you. So as you see on the right, the router disappeared, the connection is still there. Okay, the ping stopped in the first window for a few seconds, but everything came back and we survived to the failure. Okay? So let me recap you what we saw today, which is actually what we really have in the distribution you find online in the download. So basically, SDN IP can actually transform your SDN network into a transit network, thus enabling the communication between external networks. Of course, speaking BGP makes it easier for you to migrate incrementally your existing network to SDN. But there are lots of other things coming soon. These things are an host in the internal network, internally to the SDN network, will be able to be reached and we will be able to speak with the external networks. We will work more on BGP confederation. Just a few points on this. We have a very basic use case we demonstrated in our lab. We want to work on it more. Thus, bring with SDN IP the capability to scale more. And of course, deployments. We have a long list of deployments we really want to do. Some of them are already scheduled. Here I reported just the first deployment we want to do. We believe we can start easily and then scale up. So what we will do, the idea is to use the AL2S, so the production layer 2 network of Internet 2, to connect 6 universities around the country, distributed on the west and on the east coast. At the moment, of course, everything will be managed by the ONOS cluster. At the moment, each university will advertise just a /32, so it's just one route, right? So it's just a proof of concept to see that our functionalities are in place. We can work in a real case scenario. And then, of course, the idea is to scale up more. That's all on my side. If you have any question, of course, now I don't know if we have time, but for sure later on we will be there at our table during the lunchtime. Thank you.